Hi, and thanks for joining us for our talk titled A Year in the Life of a Stadia Developer. Our goal today is to give you an insider view of what to expect when making games for Stadia, especially when coming from traditional console development. Without further ado, let's introduce ourselves. My name is Yannick Simard. I'm a technical director at Stadia Games and Entertainment. I've been in the games industry for 15 years. I worked on different games at different companies such as Ubisoft, Electronic Arts, Eidos, and Typhoon. In the AAA environment, I shipped Army of Two, its sequel, two Watch Dogs, a little game called Spore Hero on the Wii, and as an indie developer recently at Typhoon, I shipped Journey to the Savage Planet, where we shipped the game in January of 2020 after being acquired by Google at the end of 2019. Over to you, Liam.
Thanks, Yannick. Yeah, so my name is Liam Flukes. I like to call myself the engine janitor at Stadia Games and Entertainment here in Montreal. I'm a generalist systems programmer. I've likewise been in the industry about 15 years. I started my career at EA Montreal, shipping some of the Army of Two games. Then I kind of switched into being a little bit more of a consultant. I was at Warner Brothers for a few years. I worked on some of the Batman Arkham games, Arkham Origins. I spent a few years on Batman Arkham Knight with Rocksteady. And then I bounced around a little bit, helping to ship games across a variety of platforms and different companies before ending up at Typhoon Studios a few years ago, where, of course, we shipped Journey to the Savage Planet. So Typhoon Studios, as Yannick mentioned, was just acquired last year. But before that, it was a team of about 25 people. Journey to the Savage Planet was our first game. And we were a small indie studio. We shipped on PlayStation, Xbox, and PC using Unreal Engine. We still kind of have kept our indie sensibilities. We're still a team within Google working together. Still a small team. So I feel like we still have a bit of a feel that we're the indie spies inside Google, that we're maintaining our indie sensibilities despite being acquired by Google.
So when making games, especially on console, there's a few quirks and specificities to how it's done. So if we take a look at traditional console development, what we see is that still people would prefer to use PC as their environment. It allows obviously faster iteration than console because of its proximity to how tooling works, and usually you might have an editor also running on your PC. So for visualization and validation of data, that's often the path of least resistance. Having said that, it's often a very good idea to start using console early in your development cycle, if only to not have too many surprises along the way and not end up porting your own game to a platform you knew you would ship on to begin with. So the kind of things you might want to put in place to ensure that minimization of surprises is to have automated smoke test, automated performance test, or even non-automated ones. So people, you could have people on your team looking regularly at the build for stability, reliability, and performance reasons. And if we compare how we make games as indie versus big studio, we'll see a lot of differences on what depends on bandwidth, capacity of production. So if you're an indie studio and a small team, you'll probably lean more heavily on a feature-rich engine like Epic's Unreal Engine or Unity. And you'll have people wearing several hats, which means that you might not have the capacity to have an entire team dedicated to platform development. So you'll end up having just the one person in charge of porting the game on a platform or several platforms. In big studios, there's a tendency of of developing a lot of expertise on teams and specialization of team members. You'll see often that big studios will develop their own engine, and it means that you'll have teams dedicated to subjects. For instance, when I was at Ubisoft, I developed the proprietary cloud simulation package for Watch Dogs, and at Warner's, teammates, and Liam worked on the Batmobile for months on a team dedicated to that topic. One thing that is common, though, that we see both on the indie and big studio side is that people tend to shy away from console, running on console regularly. Whether it be because there's a scarcity of dev kits, or because of the friction it causes when they try to be efficient in their day-to-day work. And if you intend on shipping on a new console, you'll have to go through a set of steps to get it working and be able to produce meaningful results on it. So first you need to get your hand on hardware and SDKs. You'll have to make sure that your engine supports the platform, or you'll have to implement the missing features that will make the platform run properly, your gameplay code, your engine itself. You'll have to find versions of middleware that are built to run on the console. Then you'll have to define a sort of pipeline, so it can be as minimal or as involved, but you have to find a way to put in place a build system or a method for generating your console builds, which might differ from the ones you use for quick iteration locally when you're developing. And you might want to put in place some automated testing procedures and infrastructure. And finally, having figured that out for the missing pieces technology-wise, you need to deploy that to the team. And SDK and kits are given access to the people needing them. But you might have, as I said earlier, not that many kits available, so not everybody might have access in the end to a dev kit. And the type of workflow you end up using when you work on console development is, as a programmer, you in the morning, for instance, you could be copying a package that was generated by your build system overnight. Then you deploy it on your console, and as you work on a given task, you'll just modify your executable and redeploy that custom executable over and over until you're happy with the result you obtain while working on the said feature. As content creators, artists, and other roles, it might be a bit more involved because the data set could be a bit bigger or a lot bigger if you worked on big environments and so on. So you'll have to package the modification or sometimes the game itself entirely, deploy it and run. So as I was saying a few times over, it looks like the friction to get into using regularly console is pretty high, and that's why maybe there are other ways of working. In particular, Stadia helps on that side. So Liam will go through a bit what's the experience of developing on Stadia.
Yeah, so I'll just go through a little bit some of the stuff that we've learned over the last year as we started to transition into being Stadia developers instead of being PC and other platform developers. And so some of the things that we've learned and what it might take to get going on Stadia. So as Yannick was mentioning, the steps you need to take to get set up on a console on Stadia, some of the steps are pretty similar. Of course, you need to get your SDK. You get it from Google. You download an installer, you run it, it installs your compiler and everything you'll need. If you are using Unreal Engine or Unity, of course, Stadia being a relatively new platform, you'll probably need to take a newer version, especially if you were working on a game for the last few years. The versions that have come out in the last year or so have added a lot of fixes that games that have already shipped on Stadia have kind of worked out some of the quirks in some of those engines so that it'll be a lot smoother experience for you. And that might actually end up being one of the bigger steps involved in importing a game to Stadia or in getting started on Stadia is just getting the engine up to date. Once you have your engine and your SDK, of course, there is middleware that a lot of games are using. There's a few listed there that are already supported out of the box on Stadia. So for audio, Wise and Fmod are there and running. Bing Video and Telemetry from Rad Game Tools are already there. And Havok, if you're using Havok as your physics, it already works. This isn't to say, of course, that other middleware can't work on Stadia, particularly if it already runs on other platforms, particularly kind of more Linux-y type platforms. Chances are it won't be too hard to get up and running on Stadia. So it's relatively quick. And we'll notice actually missing from this step is getting the hardware, because you don't actually need hardware in order to get going on this, assuming that you, of course, are connected to the internet. Looking at how Stadia setup works, it's actually relatively seamless. Once you have all of that set up, it's just another build target in Visual Studio or in your editor, whereas before it might have a bunch of mobile platforms, maybe other consoles. Now Stadia will show up as something else you can build from Visual Studio and as something that you can deploy to from your editor. So all of your developers are still using kind of the tools they're used to. They're still running on Windows. They're get to use all of the stuff that they're familiar with as far as creation and actually running the game. The difference being now, of course, that Stadia is in the cloud. So that has a few differences. So part of the thing that, of course, you have to set up for any platform is getting your platform set up for your users and for your game in particular. So projects, of course, if you ever worked on Steam or on Epic Games, that's kind of where you would be uploading your builds for distribution. So you set up, just your project name, and then you basically just upload your game to a place that will allow everyone else to have access to it. An application setup is more like kind of a storefront setup. So a bunch of images, description of features that your game might use if you're using multiplayer or other features. That's where you'd be configuring that in your application. And then the title is kind of the getting closer to the customer experience, where it takes the project, so the packages that you've uploaded, takes your storefront setup, and it combines them together. So once you're getting closer to certification, or you're testing kind of the whole flow, then you have your titles that allow you to get closer to an end user experience. But that setup is not too bad. And so assuming that setup has already been done, a little bit more of a system administrator or kind of a team lead type thing to deal with for a little bit. Once that's set up, it's actually extremely easy to get going. Basically, once you have your G Suite account that has access to Stadia, you'll basically just log into that on Chrome. Once you're logged into the little partner portal for Stadia, there's actually a big play button which will let you reserve an instance. So instead of having your dev kit next to you, just constantly generating heat, these instances are actually running in a data center close to you. And that's where you're going to be doing most of your development. And then you can just take one of those packages that you uploaded and you can run it on your instance, and it'll just start playing right in your browser, which is pretty cool. Of course, we're not always just playing games, despite what our parents think. So if you're a developer, there's the kind of the standard flow is actually very similar to how it worked on consoles. You can take your instance and you can mount one of the packages that, for example, your automated build is uploaded to an instance that you've reserved, and that takes a second or two at most, and then you have that entire package ready to go on that instance. Likewise, if you have a custom build that you made locally on your own developer PC, you can just upload that build directly to your instance and work with it in that way. So that's kind of closer to a more traditional console development. And actually, is also kind of the cloud in a box, so a lot closer to the other platform experience, where you can just copy a build over your LAN straight to the drive of a Stadia kind of desk kit, which works just as well as you would expect, and it works quite nicely. If you're a developer who's not a programmer, you can also, of course, access it through Unreal. So you have your ability to, you're working on a level, you can click deploy to console, and it'll do its cooking and get its executable and deploy it to your instance, either in the cloud or right next to you. And that works just as well, in my mind, as it did on any other platform that I've ever worked on. Not to say a lot of people do that, as Yannick was mentioning. It's that part misses out sometimes, but it is available. And programmers, again, it's almost identical to other platforms. There's a nice Visual Studio integration, so you're debugging within Visual Studio, you're compiling from within there. When you press F5, it'll just copy your executable to whatever version of the Stadia platform you're using. So it'll upload it to the cloud, or it'll deploy it to your little desk kit. And that's just kind of the iteration flow. So it's quite seamless. Not a big surprise for anyone that's worked on other platforms. And if anything, maybe a little bit more convenient because you don't need to juggle having kits around your team. And people can play no matter where they are. So basically, the primary way that you're going to be playing is through Chrome, which is cool. That's how you're going to be getting your input, your sound, your video, of course. Google has provided, or Stadia has provided a Stadia developer extension for Chrome, which gives you all kinds of kind of developer-specific information that's useful as you're developing the game. So it can show you your input latency, if your frame stability, what's going on, which is useful to debug because there's a little bit of an added variable now where the game could be dropping frames, or of course your network could be dropping a little bit, which would also show up while you're playing the game. And the extension actually has a whole bunch of useful features as far as when you're trying to verify your game to actually ship it to pass some of the technical requirements. There's features in there to make sure you're maintaining the frame rate, that your transitions between sound, if you're going between 5.1 and 7.1 or stereo, it gives you a lot more information to kind of start to diagnose some of those kind of edge cases that always come up near the end of game development. So that's useful for the whole team. And the whole team actually ends up using Stadia a lot more than I think we've seen in the past with other platforms. So Yannick can talk a little bit about that.
Yeah, indeed. The fact that Stadia exists in the cloud, it caters very well to some roles on the team that require to have access to a build, especially if your team is over different regions in the world. You'll get a great benefit from the fact that Stadia in itself is a distribution system. So you push the build, and there's a whole sets of steps, domino effect of getting that build ready to be used by anybody who would at the click of a button. So the kind of use cases for which it's very convenient are for QA and production in particular, being able to review, test the game, access with a group of people. You simply push your build, whether it be at the nightly builds or for milestones or internal demos and tests. And as I said earlier, you just click on a button and it plays from anywhere or any endpoint. So on that topic, one great thing is that the fact that Stadia is essentially just a thin client implemented whether on in the browser or natively on a device, it doesn't require a lot of power to run. It only requires the ability for the device only requires the ability to access a stream of video and send inputs, and in the end, it means that you can play AAA games on very thin and low-powered GPUs, such as what you would find on random tablets or mobiles, or you can also play on your TV through a Chromecast. But there are still some things to keep in mind when you try to access and deploy your game such that it is playable on a lot of endpoints. As you see in that little clip, not all the aspect ratios are the same. The screen size are definitely not the same. So you need to take special care as far as certification goes. On the endpoint side, it will be mostly technical requirements. But at Stadia, there are also what we call the storefront requirements. So basically, you need to create a manifest of what kind of rating your game has. You put your screenshots, trailers, which languages your game is localized in. And going back to technical requirements, because Stadia uses Vulkan as its low-level graphics API, we have a special validation requirement, since we can run on so many devices and we support different controllers, you have to take that into account as well. Frame rate is also in the requirements in the form of having a certain fraction of frames that are stable, 4K and HDR as well as, and finally, obviously stability, where you don't want to have your game crashing. But that's quite in line with what you would have on console. However, there are differences, and Liam will go through a bit the quirks that you can find on Stadia.
Yes, thank you, Yannick. So yeah, of course, especially a new platform, and a platform that's kind of unlike any other platform that most people have been shipping on. There's a couple quirks to keep in mind. So we're going to go through a few of them that I found a little bit surprising over the past year, and maybe it'll come in handy. So as Yannick was mentioning, Vulkan is different than other platforms for sure. Xbox and PlayStation aren't using Vulkan. Maybe if you've come from an Android development background, you'll have a little bit more experience. We mention it. If you're using Unreal or Unity, chances are most of the problems, or not problems, but most of the complexity with Vulkan is going to be hidden from you blissfully. But chances are, if you're pushing the limits a little bit, or you have some ambitious tech artists, you may still have to go in a little bit and make sure that your Vulkan shaders are compiling and that you're getting the visual output that you're expecting. So not a huge problem, but something to keep in mind. Also, there's no platform MP4 movie support on Stadia. So if you have a game that runs on every other platform and every other platform is running MP4 videos, no problem. You might have to, it's not a big scramble. You might have to scramble a little bit though to either convert those movies to something that's better supported on Stadia, or figure out a way to play MP4s with some other middleware, which also exists. It is a request that the Stadia team, I think, has taken into account, so that this may improve over time, but just something that caught me a little bit when I first started the transition. Of course, also the development in general now is happening in the cloud, so not having that dev kit right next to you does open up a few other development quirks, like if you have tools running on your development PC that are used to being able to communicate at all times with your development kit. The fact that your Stadia instance is in a data center with the firewall, chances are your computer is running, its own network with its own firewalls. There can be a little bit of legwork there to get those development tools communicating properly while the game is running. Not impossible, just something to keep in mind. And then the final thing that is just a little bit different is Stadia, of course, supports achievements, but it actually requires games to support gamer stats. So other platforms also have the ability to track stats as people are playing through the games and present them, but on Stadia it's mandatory. So if your game doesn't have those and you're thinking about moving it to Stadia, just something to keep in mind relatively early to get yourself prepared to add that support. Just to go back a little bit into Vulkan, if you have shipped a game on DirectX 12 on Windows, there's kind of an extra step that's not required on other platforms, and that you need to get all of your pipeline caches and your shaders compiled before you're actually shipping the game. Without that, every time you hit a new shader, there's going to be a little bit of a hitch in your game as you're developing, which is fine during development, but obviously the end user doesn't want to have those hitches. You want a nice, smooth experience. So if you've already shipped a game on DirectX 12, you probably already have a process to gather all of these pipeline states so that when you make your final build, you don't have those hitches. Stadia, that process is relatively the same. And it's also something that's being worked on actively at Stadia to kind of make it easier for developers to kind of gather those through development so that you don't have to kind of scramble at the end to smooth out your frame rate. So just some things to think about earlier in development. I know that's kind of a funny thing to say to game developers because there's always too many things to actually address any of them early. But some of these actually would be a lot more work to address really late in the game and a lot riskier. So as Yannick was mentioning, 60 frames a second really feels a lot better on Stadia. It makes it a lot smoother. It makes the experience better. Running at 30, it just doesn't feel nearly as good. So it's something that you really want to keep in mind, that you need a strong, smooth frame rate. Those occasional dips you feel, I noticed that I feel a lot more. If you're porting a game that was running at 30 frames a second on console, getting it to 60 frames a second on Stadia isn't too big a task. So that's not an impossible task for an indie studio to achieve without too much work. But it is something that you'll want to keep in mind while you're getting it used to Stadia. Another thing that Yannick mentioned is the controller remapping. That's something that, if you're on a console, chances are you weren't supporting the other console's buttons in that same build, and you definitely weren't supporting hot swapping between them and having the icons adjust appropriately. So having the ability to do that, if your PC build is already doing that, you're way ahead of the game. And also swapping between mouse and keyboard and those controllers and having the icons update. It's not an impossible task again, but it's something that it's nice to have built in earlier on. Another thing, again, that kind of in the UI genre is if you're playing the game on a huge 4K TV versus playing it on a very high DPI phone, those UIs are going to have different readability requirements. You may need to adjust your fonts, maybe adjust some of the UI within the game. Maybe you take some away on smaller screens to just make it clear to the gamer what the most important thing is. Having that be adjustable also helps the accessibility of games, so it's probably a good thing to do regardless, but it's just something to keep in mind. And the last thing is, if you're in a work-from-home environment, which a lot more of us are, setting up your build pipeline so that builds can be distributed from places with very strong internet, for example, from an office or from somewhere else, and then being able to iterate on those builds is actually very handy and will make developing on Stadia a lot easier. So spending a little bit of legwork earlier on in development to make sure that that's smooth definitely makes things a lot nicer as far as Stadia development. So these are all kind of quirks on Stadia that you want to keep in mind. However, there's also a lot of cool stuff on Stadia that makes it a cool platform to develop for.
Yes, indeed. So thanks, Liam. Stadia is a non-traditional platform, a non-traditional console, but it was born out of the cloud, so it brings a lot of very cool opportunities along that birthright, if I may call it so. For instance, some Stadia exclusive features like Stream Connect are typically quite hard or costly to implement on traditional consoles. Basically, having the ability to see full detail viewport of each of the players you're playing with in a game without affecting performance, because in this case on Stadia you're just connecting the streams together. You don't need to re-render the scene several times. It opens the door to having interesting effects like this one without incurring too much of the cost. The integration with YouTube or social media or the web in general, that's another advantage that you get out of Stadia. So basically, you could be sharing a link of the state of the world that you as a player created, and you send it to a friend, and that friend just clicking on the link is brought straight into their game, but with the world as you defined it through your state, through state share. So it's a very interesting way of sharing sharing through the web, or the different platforms that you use to visit when you're on the World Wide Web. Finally, the fact that the games are in the cloud, and the fact that they run on a device that resides into a data center, it gives a lot of advantages that you can take for your own and use to their fullest. So basically, in a data center, the instances have are running hardware that allows for super high bandwidth between games, very low ping, very reliable ping. So it changes the type of challenges that you have to overcome when trying to make a great multiplayer experience. So maybe you'll notice some of the challenges going between the player and the instances, but from that point on, from the Stadia instance to the rest of the cloud, you have a lot of power you can leverage. And speaking of which, the integration with Google Cloud, the Google Cloud Platform, pretty much renders infinite the possibilities, because you basically in the end have a supercomputer that you have access to through a browser running on a very low powered device. So as a closing statement, think about all the possibilities that these kind of doors open for the future, and I'm personally looking forward to see how crazy great game developers will push the envelope, will go, how far they will go, and how crazy they will go try and exploit these new capabilities. So I thank you very much for listening to us today, and see you around in the game industry.
Thank you very much. Thanks for watching.